All right, so today in our second video in our development vlog for the game Jerboa Wars, we are going to continue where we left off last time. Last time, if you remember, we've set up the whole kind of infrastructure, the whole solution infrastructure, I would say, for the whole project, and an empty vessel, so to speak. So today we are going to start actually writing some code. So let's see what's on the agenda. First and foremost, we're going to add the Pixie.js dependency to our JScene project that we've created last time. And that is, of course, will be done with the help of the Spontif's Blazor Pixie.js wrapper. We are going to add the JScene class into our JScene project. That is going to serve as the main sort of view model for the whole the whole root of the scene that is going to be drawn, of the graphics for the whole game, and that will be supplemented with a view, which is going to be a razor component that will have the actual HTML element and some logic to communicate with the JScene and Pixie.js and everything, to draw out, to output the graphics on an HTML page, right? And then we are going to create a basic scene abstraction, scene tree abstraction, I should say, and that is because the way the graphics usually organized. Anyway, it's not only 2D or 3D. Anything is sort of a tree pattern, a tree structure, I would say, where we have some abstract interfaces and classes that will serve as the basis for the nodes in that tree. So you'll see. And then we are going to draw some sprites. Well, actually just one sprite maybe. So the idea for today's video is to actually set everything up, connect the libraries, and create a basic testing application for Wasm, testing application in Wasm, Blazor Wasm, to have an actual image displayed, just static image for now, just very basic thing, and then we'll build on that in the next video after that. So before that, let's look at what we're actually going to be using, what libraries, as in the previous video was mentioned. All of this was mentioned in the previous video. We are going to be looking a little bit into how all of this works now, because we need to include it in our projects and see how that can be done. So let's look at a all right, so this is the website for the Pixie.js JavaScript library. As you can see, this is an HTML5 creation engine, as they call themselves, which is quite accurate, I would say. It is a library written in JavaScript that helps use assets, I would say, in graphics and draw them with WebGL, which is a technology that connects your browser to your GPU in your either in onboard GPU or external GPU, whatever, and have the graphics drawn beautifully and quickly right inside your browser. And all of that, of course, sits inside the HTML canvas element. That is all supported by pretty much every modern browser right now, so don't need to worry about that. But the way it is set up, that you can see all of the tutorials, guides, and examples here. The basic idea is that you have this element, like let's see, a container. The way this is, the very first example that they have, if we can just quickly look through it, this is all in JavaScript. Of course, where the core of the main object is your application that is just instantiated, and then inside that application is this application has a canvas property, which then generates the actual canvas HTML element, and could be appended to whatever container you want, HTML container there. And from that point on, it will render graphics inside that canvas in the form of sprites usually, or graphics or text, whatever, and it's organized in this render tree where you have the root, and then you can have add children, and these children can serve as containers for more children and so on. And all of these transformations, they propagate down this tree. Very standard and quite nice setup, I would say. But the idea, the pipeline is usually you create your application, you create your render tree, and then you add all the way up here. You load the assets, you create the sprites, you set the sprites properties or container properties, all of this stuff, and then you have an async ticker, which is kind of like a timer that executes every frame in this case. And this is where you can code all of your transformations. In this particular example, we can see that there is a texture with a bunny. There is a container with 25 of these bunnies all in one place, and then the container itself is just rotated, and that is the result. That's just the basic setup, and but this setup kind of it holds through most of the stuff that we need. It just gets more complicated in terms of what you want to draw, how you want to draw it, how you want to set it. And you can see that the Pixie.js in itself is not like a very I would say abstract engine, where say if you have something like a Unity, something like Unity, or where you have something like Unreal, where you have all of these tools, everything is abstracted way high above all of this. This is not it. It's still a very nice abstraction above WebGL for a specific purpose of 2D graphics, but it does not provide much in terms of high level abstractions for how you set up your scene and things like that, which is, in our case, I think is great because it gives us a lot of freedom in how we can, we have to set it up ourselves. And we have our tools, and we have our languages, C#, JavaScript, all of them to get it done. And this is the freedom I was talking about last time that I really appreciate. And it's nice to have a library like this wherein. All right, so this is Pixie.js, and another thing we'll be using is the SpawnDev's Blazor.js Pixie.js wrapper. As we talked last time, by his handle is Lostbeard on GitHub, the developer, and they have other nice projects, as you can see here, a bunch of different projects. The main one is the JavaScript interop, this one, that Pixie.js actually is using, of course, and I bet most of these projects use, because it all revolves around the communication between the WASM layer and the JavaScript layer, and all of that done is through his Blazor.js library. But the Pixie.js is a wrapper for Pixie.js using this interop method. All right, as you can see, we have a Nuget package here that we will be adding to our application. And another thing that we'll be using is this Blazor Bootstrap wrapper, which is also a pretty nice thing. It just has a lot of these standard Bootstrap components that have been wrapped for Blazor. And it's not necessarily just WebAssembly. It works server-side and side. Like, this is a really nice library that just makes working with saves a lot of time when you want to style your stuff on your in your website or in your page in Blazor. Also free and open source, really nice. Has a GitHub, and there is a Nuget package as well that we will be using. Now, let's go back to the presentation. That was that. Next thing is let's look at the class that is going to be the core to our graphics rendering engine. So so to speak. We call it JScene. J stands for Jerboa, as in Jerboa game, whatever, Jerboa Wars, right? So this scene is going to be a kind of a view model, as I mentioned earlier. If you've ever worked with something like WPF, which is an object that will be directly influencing the actual view of a view component that we will be building together with it. And the view component itself is going to be very kind of simple in a way. There's not much in it, as well as JScene is not that, the class itself is not going to be that that large or that complicated. It's just a container for the tree, for the assets, and for everything else. And that's what we're going to have. And this is, of course, not a complete thing. We're going to go step by step. As I've been developing this, I'll be adding to this class and adding to most of the classes as we go. But instead of like having everything there from the start, like I said, it's better to kind of build on progressively on our architecture. So for now, for this video, we're just going to have the textures wrapped, which is a way to load graphics data from files, from image files like PNG or JPEG, any kind of graphics files, from a URL to that graphics file. Then we would have a basic render tree setup where well, the only tree, I would say, well, the two concrete tree components that we'll be implementing today is going to be the container and the sprite. And it will have a render method that is actually also not going to be used that much right now. And it will all make sense after we get deeper and deeper into this project and start populating all of this. So it's going to be pretty much some of this stuff will be empty for now. One other thing is that the way the Pixie.js is initialized in Blazor through SpawnDev's library is that it needs to have a well, it has to inject itself in certain places in the whole project initialization stage, and that's why we'll have the static method that will actually be called at the very beginning of the whole project initialization for the test at this point, and later the actual game. And we also need to have this view model as a disposable, as implementing iDisposable interface, because specifically the JavaScript interop uses something that's called the references, object references, to communicate between the JavaScript objects and WASM layer. And those kind of, they are not, I wouldn't say they're unmanaged, but in a way you have to kind of keep track of those. And sometimes like the garbage collection, I don't know, maybe it's better now. It used to be in the past when I worked with the older versions. What happens is that older versions of Blazor, say, or ASP.NET and WASM, is that the browser is not actually, the application, the server may dispose of those, but the client side, when you're working on the client side, you're relying on the browser disposing of that memory. And that is like the garbage collector in .NET. Maybe I was doing it wrong, would not automatically do it sometimes, and it created a sort of like memory leaks on the client side and the browser. So I'm kind of cautious about that from that point on. It was, and now I always, whenever I have some references between WASM and JavaScript, I always make sure to manually have them disposed in my applications. So that is why the JScene is going to, and all of the stuff that is referencing the the JavaScript objects is going to be disposable. And that, of course, also actually it's not just me, I guess, because all of the SpawnDev stuff related to JavaScript also follows this very closely. It has everything. It has to be disposed manually when working with JavaScript interop references specifically. Anyway, so the JScene object, the JScene view model, will be supported by two other components. And one is the actual, as we said, the Razor component that will be a physical connection to the front-end HTML page or the Blazor page, Razor page, I would say, between the backend scene and not the backend, the view model and the document, the HTML document. And another thing is that we want to expose a service, which is the JScene Builder service, that is going to be used to initialize and set up the scene before rendering. And the way it's done, the way I decided to do it with this Builder service is because there are actually kind of two stages to how the Pixie.js is initialized, as you've seen in that example. The first stage is the asset loading, where you are actually loading data for all of your assets, or some of your assets, I'd say, in the beginning, and in bigger, more complex scenarios, you would have some kind of dynamic asset loading and things like that. But for in our case, the game is very small. It's like simple. There aren't that many graphics. Actually, not going to have more than a couple of textures with all of the sprite sheets on them. And there's no need to have a dynamic asset management. So all of the assets are loaded in the beginning at game initialization. And that is one of the steps in the scene builder where you can customize what kind of assets you want to load into your scene. And then the second is after the scene is initialized and everything, that is the second step in the builder is to handle the scene initialization. It's when you already have your assets, what do you do with them? And that is where you would build your render tree and things like that. And this is where the other components that we'll be building way into the future, they will be plugging into this stage of scene initialization to actually inject instances of different game elements, including, again, all kind of nested and things like that. But that's not something we need to worry about right now. So let's see how this pipeline actually works. We have the Razor component. When you go open a URL to that page, that Razor component is part of the render tree for the Blazor, for the Razor page. When the renderer gets to it, it starts initializing it. At that point, the Pixie.js is initialized, and that is the initialization of some of the stuff that is done through the SpawnDev library. And then we have the builder. Once the Pixie.js scene is initializing, it creates a callback to the service of this the scene builder service that allows the application to handle things like asset loading and render layer creation, things like that. And then after that callback is done, there it is, actually says asset loading, and JParts asset initializers will be tapping into this callback to do their thing later on. Not today though. And then the builder calls the actual build method. That is when all of the things like these assets and textures and everything is loaded. That that is an expensive procedure because it actually calls, it does some API calls to or I would say rather, it makes HTML requests to these assets based on their URLs and things like that. So all of this is asynchronous, of course. And after the build is done, that's when the second stage I was talking about in the builder is performed, which creates a scene initialized callback, at which point the application or again the JParts initializer, they need to actually build out the scene using all of these assets and things like that, and build our render tree. And that's pretty much the gist of it. And then from that point on, this is the initialization, and then the game goes into this render loop and then starts rendering frames based on everything that's been set up. All right. Now let's look at the render tree itself, because we need to create some kind of common abstraction for all of these elements of this render tree. And so far, this is what we will be implementing, and of course, it may grow later as we go. The main abstraction is this interface that is going to represent a scene object, and a scene object is an object that is present in the Pixie.js render tree. It's not necessarily a visible object because containers are also part of the render tree, and they're by themselves are not visible. They can contain other visible objects like sprites and things like that. And we are going to be wrapping all of that with our own within our own architecture, and that is what we like. So we're kind of taking the Pixie.js tree and wrapping it into our own tree in a way. And it may not make much sense right now, but as we go, you will see the reason for the way this is set up this way, because we will have to actually augment and change a lot of stuff in how, well, not a lot, I say, but there are some critical places that we need to adjust and change in order for this thing to work properly. And we'll see how that is done in later videos. So the IScene object interface, that's the one that has all of the kind of the reference to the Pixie.js container and all of the basic transformable properties such as position, rotation, scale, alpha coefficient, and things like that. You will see. And then we will have an abstract class JSceneElement that will be implementing this IScene object interface. And it will have a generic type argument, which is going to point to what kind of Pixie.js render tree element is going to be represented by this particular implementation of JSceneElement. And from there, we will have a JSprite component that is a concrete class now that is going to be extending the JSceneElement, where the generic argument type is going to be the Pixie.js sprite. So that is how we're going to wrap the Pixie.js sprite into our own sprite and then expose it to the IScene object interface. And another thing is going to be a JContainer, which is the same thing. Is going to extend the JSceneElement, but the generic type in this case is going to be Pixie.js container, not the sprite. But they're both going to be inheriting from the same class, and therefore also implementing the same IScene object interface. So as far as our engine is concerned, there's a lot of these, like all of these properties, like position and scale, like we're talking about rotation, they will be generalized by the IScene object interface, and independently of what the underlying actual Pixie object these classes are wrapping. All right, and this is what we will be implementing today, but the tree itself is going to extend later into a JText component where you can draw text. The JSprite will be also extended into a JGrid sprite, which allows us to, because the JSprite is only one image, but JGrid sprite will have the opportunity. We'll have the opportunity to have multiple images stored within one object, and then could be dynamically kind of be assigned which of these frames to draw from a collection of these textures. That one, actually, we'll be doing that in the next video. This grid sprite, because that involves also some extension building for the Pixie.js wrapper. And that is also, it may be interesting as well, because we will be adding some stuff to the SpawnDevs, extending it in a way that is missing there at this point. Then the J container will extend into J particle emitter later on. That's going to have a kind of a container with multiple sprites of the same type that are drawn in numerous numbers. It's like, for example, the smoke coming from a rocket. That's a particle emitter. It kind of generates the positions and transformations of all of these little smoke sprites on the screen in real time using a set of mathematical functions. And all of that is wrapped into this particle emitter, so we can just put it on the scene in our render tree and say, hey, this is a particle emitter, this is the particle you're going to emit, and these are the functions you're going to be using, and it's just going to be doing it under the hood, things like that. And then the next thing is going to be a JView with another generic type, and that extends the J container. And that is going to be an abstract class, actually, that is going to be the root of the hierarchy for all of the views from the JParts library that we are not going to do today. Again, we will get to it. And these are the more like high-level abstractions for all of the game parts, things like the game view and the text presenter and the board view and the character view. There are many of them, many more. It's just an example, and there will be probably more than I have right now by the end of the development, but not probably, definitely. But this is the kind of the gateway, the JView class, having the J container as the basis for it and adding some stuff to it will be the gateway to the JParts library to implement all of the views consistently and insert them into the render scene tree. And the generic type component will be representing the models behind each of the view. So, for example, if we have a board has a number of cells in it, and then there is some logic into how the board behaves, how the cells are organized, and all of that will be part of the board model. But then we also will have the board view, which is going to have the board model as this generic type argument. To leverage the kind of have this natural separation of concerns in how we develop the relationships between the views and the data behind it and all of the logic that runs in between. All right, but that's the basic setup. That's once again we will be getting to the JSprite part and JContainer part today, and you will. But that's that will should give you a pretty good idea on how all of these things will be working. Even though, again, I will mention it again, we will be redoing a lot of the stuff that we do today. Well, maybe not so much redoing, but adding to it in the next couple of videos. Because, like I said, there is an issue with the speed at which JavaScript interacts with the between like the WebAssembly. I would say there's an issue with the speed of data transfer from WASM side to JavaScript, and that is kind of the thing. Is like the Pixie.js is so fast, the graphics drawing is so fast, everything is so fast. The WASM is pretty fast. Everything like works great, but the only thing that is slow is the communication between the two. But like I said, there is a way to mitigate that for the most part, and that will require some interesting implementations in these underlying in this underlying architecture that you're seeing on this slide right now. Anyway, we'll get to it. So that's it for the presentation. Now let's jump into the Visual Studio and start coding. Back in our solution in Visual Studio. So we'll start populating the projects, mostly JScene for today, with all the stuff we've talked about. And the first thing we're going to do, we're going to add some dependencies. The JScene project depends on the Pixie.js wrapper. So we're going to add a Nuget package for that. Let's see what we have there now. Actually, first let's update our existing packages that we have to the latest versions. Always a good idea. Not always, but most of the time. Let's go to the Nuget package manager. Let's see what we have there. Are there any updates? Yes. So we can update some of our Microsoft components, .NET components, ASP, and stuff with the latest version. Let's do that. Update everything. Okay. Now we are going to add a Nuget package for Pixie.js to our JScene. Actually, let's do that with a package manager. It's much faster because where is it here? We have the link to the Nuget package right here. I can just copy this command, our package manager, paste it here, and let's see. So we're getting some errors here, and let's see what it's all about. Yes, so ASP components WebAssembly. I see. So the SpawnDevs library was built on the WebAssembly dependency from .NET 8, and we have .NET 9 right now. And this specifically the WebAssembly package. And because the JScene, we don't really have the WebAssembly yet. So let's add that first. We need a this package actually, Microsoft Components WebAssembly. Let me copy this. Manage Nuget packages. Let's browse Nuget and let's find it. There it is. So version 9.05. Let's install that and let's see if that helps. Okay, so we have it here. And now let's rerun the command. Where are we here? And we're good. So now we have the SpawnDevs Nuget package library included in our JScene. Good. Now let's start building some stuff here, right? First thing, we are going to add a JScene class. Well, actually, let's start from the bottom. I'm gonna add the render tree because the JScene will then have that as one of its properties. So we'll start with the interfaces. Let me do it off screen so I don't waste your time. Okay, I've added this interface. That is going to represent like a couple of interface file with interfaces, some declaration. Is going to add the IScene object interface first. This is the one that we've talked about in the presentation. The main interface for the object that is going to be the generic, the most abstract part of the render tree. And let's look at it, what properties it has. That the classes that implement this interface need to implement. We have the ID for the object and a name to have it as part of the dictionary inside its container. reference to the scene and references to the container, the Pixie.js container. By the way, this one we can JContainer, not the Pixie.js container. And this is the reference to the parent container, which we are going to have in our JScene as well soon. We'll add it next, actually. So now that we have the interface, we are going to add a first abstract, the class at the root of this hierarchy, the root of the inheritance hierarchy. And that class is going to be the scene element, JSceneElement. Okay, so I've added this class, and we can look at it now. We have this now. We have the interface, and we have the JSceneElement, JScene, and as you can see, this is the JSceneElement with a generic type. That the type is has a constraint on it that it has to be inherited from the container. As you can see, this is the SpawnDev's Blazor.js Pixie.js container that is the wrapper to the Pixie.js container render tree object. And so we will have, today we're only going to implement the sprite and the container on this, the two types that are going to inherit from this abstract class. Here, as you can see, because it's implementing this interface, right now what it's doing is, because the container represents the actual reference object to the JavaScript side reference. And this container has the properties that directly get the value or assign the value to the JavaScript object through JavaScript interface. And right now I have it as just like all of them as one-to-one getters and setters. So whenever we set the, say for example, the property X on our JSceneElement, it just immediately translates it to the container X property, which is then sets the JavaScript, the object that is referenced in JavaScript, and the property to whatever we're setting the property, getting or setting the property in our element. And this works, but it's, like I said, this is not scalable at all, because every time the property is set, or whenever you're getting the value for the property, or you're setting the value for the property, it goes through the JavaScript interop layer, and the objects are serialized back and forth into JSON, and that slows down the whole operation significantly. And because the game is, the application itself is graphics heavy, which means these properties need to be updated multiple times on many different objects on the scene, and it has to happen 60 times per second for each frame. This just you will see that there's not a lot of stuff that can happen on the screen before the frame rate starts dropping like really fast. But for now, let's keep it like this, and all of this we will redo it in the next couple of videos, where we will refactor, not even refactor, I would say re-architect the data transfer between these objects and the JavaScript. All right. Besides the properties that are directly linked to the Pixie.js container, we have some constructors. Again, for now, we don't have these classes yet. That's why we're getting these errors. That's fine. And one other thing, and there's not much else. Again, we have the disposer because every element that is connected to drawing things on the screen, therefore, has a .NET reference to a JavaScript object. It needs to be disposable. And as you can see, the IScene object interface actually, if we look here, you can see it also inherits from and implements the iDisposable. So whenever we're implementing ISceneObject, whenever we're implementing the ISceneObject interface, it also requires us to implement the dispose method here. And what we need to do here is we're just disposing of the container, because the container is the reference to the JavaScript object under the hood, and that is also disposable. And because we have the ET, the generic type restraint to the container, that's why we can do it. We have access to the dispose class, dispose method in that class. All right. Besides the abstract JSceneElement standard JSceneElement definition, we have we declare another class here that represents the dictionary, and that is inherits from a key collection where the scene objects are indexed by the index within their parent zero-based index, just like a list or an array, and also have the string key like a dictionary. So this is both the key collection is very useful abstraction that's been in .NET for a very, very long time. That lets you basically create a dictionary and a list together in one collection. Very useful with minimal efforts. And all you need to do is override the get key item and return the key, which is string, from the item itself. And because the name is the property of the item, which is our ISceneObject, it can serve as a key, which means that within this collection, only items with unique names can be present. So each element within a container needs to have a unique name, therefore. Another thing that we have here is an event handler on when the item was inserted. And as you can see, we can easily override this insert item method on this key collection and have that event handler called. And that is very useful is when you're creating a new, you will see that how it works. It's not really that important, but it just simplifies it a little bit how the items are added. What you can perform custom actions on the items as they're added to the collection. All right. So now we have our interface. We have our abstract JSceneElement class. The next thing I'm going to add the two concrete implementations, extensions rather, of this JSceneElement class, which is the container, the JContainer, and the JSprite. Okay. So now we have these two classes added, the sprite and the container. Let's start with the container. As you can see, it implements the JSceneElement, extends the JSceneElement class with the generic type container, which is the Pixie.js container, is wrapped by Blazor.js, Pixie.js. It's also, because it's a container, it's also a collection, so it collection of its children. So it implements the enumerable with ISceneObject generic, which means this container can be iterated over with each element implementing the ISceneObject interface. Now what we have that the container itself, the overridden one, is the generic class is the Pixie.js container. We have it here. It does not need any custom initialization really, so we can just create it along with the initialization, like with the construction of the JContainer class. That is not the case with Sprite, for example. You will see we cannot just simply do, because it needs the Sprite needs a container. Container does not need any parameters really, arguments for the constructor. One thing I forgot to mention on the JSceneElement generic are the protected constructors that we are going to override. So you can see we have two constructors in our abstract class that all of the descendants of this abstract class need to actually call within their constructors as well. And there are two modes how this class can be instantiated. Well, the descendant of this class can be instantiated is when the J container is provided as a parent, or the scene itself is the JScene itself is provided like at the root. And also we need to supply a name, because the name of a component within a container has to be unique. We have to keep track of that, and that is part of the initialization of the object itself. And it's very simple. I'm just setting the name and the scene, and here I'm calling for the when instead of a scene we have a parent container. I'm calling the initial constructor with the scene of that parent. So we are putting this, the scene reference is going to be the same for the child as it is for the parent, and we are just setting the parent property to the given argument here. All right, that is on the abstract class side. But now, because both of these constructors need to be called during construction on all of the concrete implementers, say in the container, the way it's done here is that the same thing. We have the J container, we have the scene and a name, and we are calling the base constructor with the same arguments. But what we are also doing, because the children, as you can see, the scene object dictionary is the one that collection that is declared here along with the JSceneElement, if you remember. That is the one of the properties of the container is the scene object dictionary, meaning container can contain other scene elements as children. We need to initialize that. Well, not initialize, but we need to do something with it in order for it to capture the children as they're being created. And that is done here in the constructor, where we are adding this event handler for this children collection to when the child is added, inserted into this collection, the container, the Pixie.js container, at the same time automatically has that child's container inserted as a child. So it's kind of like the duplication here of collection insertion. On one hand, we have the higher level J container accepting the IScene object, the class that is implementing IScene object as a child, and IScene object has the container which is the Pixie.js container as its properties. And both our J container has the container and the child IScene object has the container. So as we were inserting the IScene object into our J container, at the same time we need to insert the IScene object's Pixie.js container into the container of the J containers container. Okay, that was a mouthful, but I hope you understand what's going on here. If not, it's not that important. The idea is maintaining the hierarchy on both ends. This is like the WASM end, and then this is the JavaScript end. All right, and then as this particular instance is created, we are adding this instance to its parent, provided the parent is given. The parent is valid, like a valid J container, which it should be. All right, and for the scene, we're just adding the container without the parent, but still have the child, the children event, children collection event, handling all of the additions when this container accepts other elements, scene objects as children. All right, so that's pretty much it. That's all. There's not much going on here. We have the disposable, and we have some stuff here about the collection management, where we can reference the child by just giving an index, or we can reference a child by giving a name, a string key, which just returns the children, the element from the children collection by the key. And we have some methods to add, remove, and insert children into this collection without having to deal with this property at all. Even though like you can't even do it from the outside because the property is protected. It's only seen by this class or all of the descendants class. So if you want to add a child to this container from outside of this class, you will have to use these methods as opposed to, because there's no access to the children property here. All right, and that's about it when it comes to container. So it's just an element that can, in principle, just hold other elements inside of it and other containers. So it could be a true tree going as many levels as you'd like. Now the sprite, the JSprite also implements extends JSceneElement with this sprite, the PixieJS sprite wrapper, as the container. And all we're doing here, the same thing, we're just assigning the container to, we're creating a new sprite. As you can see, like this is what I was talking about. In the container, when we are creating the PixieJS container, we're just adding calling the constructor right there as the class is being instantiated. We don't need to put it like in the constructor. But here, because there are no parameters, no arguments to the constructor. But here, because the argument has to, we need a texture argument, because for a sprite, we need a texture object that is linked to this sprite. And this texture becomes, is one of the arguments in the constructor of JSprite. We cannot instantiate it right here. We have to instantiate our container, PixieJS container sprite in as instructions inside our constructors. I mean, it's not really that big of a deal. And then the same thing, as we are creating a sprite under some JContainer parent, we're just adding the instance that we're creating immediately to that parent. And when this happens, the event handler on insert is called on that parent that inserts the actual PixieJS container into the PixieJS render tree right there. So this is this relationship. Okay. Now, this is pretty much all the setup for now that we need to draw to manage the render tree for now as far as drawing sprites. However, what we also need is now we need the JScene itself, right? And like it was shown in the presentation, JScene is kind of like the view model class that will house the render tree, this virtual kind of render tree. Let's kind of separate it into this. I would call it the scene tree that we are building here, the scene elements. We could call it the virtual WASM side kind of tree, render tree, or scene elements tree. But it is kind of wrapping itself around in a, let's call it, less virtual tree that is PixieJS is managing with all of these, through these container properties. And what we need now, we need the same thing for the scene, where we're creating kind of this virtual scene, which is the JScene, that is wrapping the PixieJS kind of root scene object or set of objects. And that's what we'll do. And then we'll have the whole thing kind of like virtualized. All right. How do we do this? We need a class, a JScene class, and then also a Razor component view that kind of uses that JScene class as a view model. Let's do that. All right. So first JScene. All right. So first JScene. And JScene implementing iDisposable. As mentioned, everything needs to be disposed in anything that has to do with JavaScript, not just JavaScript interrupt, but have a references to objects in JavaScript. Those need to be disposed. All right. So the JScene object, again, this is just the first cut of it. There'll be more stuff here later. I do have the sprite grids comment it out for now because we're not dealing with sprite grids today. But the main, let's look at the structure of this class, right? So first we have a few properties that reference the runtime, the Blazor.js runtime that we will need actually later on. We're not going to use it now, but we will need it. If not in the next video, then in the video after that. But this is the SpawnDev's runtime that allows for this very nice JavaScript interoperability that sits on top of the normal Blazor JavaScript interop. Then we have the application wrapper. This is the wrapper for the application JavaScript application class here. Actually, we can look at the API documentation here for Pixie.js, and all of these classes are here. They are just wrapping the SpawnDev's library wrapping them applications. So we have the application class here. It says convenience class to create the new Pixie.js application. Class automatically creates the render, the ticker, and the root container. And that is exactly what it is here. He even copied the description exactly as it is in provided the link to the Pixie.js API. We will probably, depending on interest from people, I may dive deeper into how the Blazor.js runtime is implemented. It's really clever the way SpawnDev did it, so it might be interesting for people to dive into that a little bit. So let me know in the comments below if you're interested in that. If you'd like to kind of me have a little go at it in a separate video, because it's not really related to this so much to this development. But it is neat. I really it took me a little bit to figure out how he was doing that. But after some time, yeah, it's really nice. Anyway. And then we have the document, which represents just the HTML reference to the HTML document object on the page, which again we are probably not gonna do much with yet. We're just gonna get it and then we're gonna dispose of it at the end. And here's the dictionary for the textures. These are the assets that was like one of the types of the assets that we're going to be having. For today, it's only the textures, and the texture is an object that represents an image with pixels that could be fed into the sprite data to be shown on the screen as an image, and then transformed, position, rotation, and things like that. The texture class itself is the SpawnDev's wrapper class, which wraps the texture from Pixie.js directly. So if you look at texture class here, you can see that this is the texture stores the information that represents an image or part of an image. Texture must have a loaded resource passed to it, blah blah blah. All of the members of this class. So the same thing here. The SpawnDev's texture implements that nicely. Well, some of it, not everything, but everything that we need is there. Now, this is the asset dictionary, and we will have just textures indexed by name, by their key. So each texture will have a unique key, or rather, the key is the URL to the texture, because the texture is fetched into this environment with an HTTP client under the hood. It just grabs it from a URL. So the same URL to the texture is a unique URL, and it serves as the key in the dictionary. That's about it. Now we have our JContainer as the render tree. So this is the JContainer that we've created now. So it is a node in a tree that has a parent, or may not have a parent as if it's at the root, but it may have children, elements, scene objects of other containers or sprites or what have you as children, and then propagate the tree down further like that. But at the root we have just one, a root tree container that will have the whole kind of game rendered inside that container. And once we have all of that, we have a constructor for this class that only accepts 2 arguments, the Blazor.js runtime, which will be injected at the component level, at the view level from using dependency injection. And then when the JScene is initialized, it will be supplied to the builder, and then the builder, we'll talk about the builder in a sec. The builder will then instantiate the JScene, providing the Blazor.js runtime argument as it was injected already. And then we have the same is application. The application instance will be created before the JScene, and that by the builder, and the builder will supply that as an argument. And here we're just assigning it to our scene, to our properties, the JRuntime and JS runtime and application properties. The document is actually a method on the JS runtime where we can get the document element out of the JavaScript runtime like this. So it is assigned dynamically here. And then we are just instantiating a new render tree object, which is the container with the within the scene itself. So this render tree is the only container that does not have a parent in this scene. Every other container or any scene element will be part of the tree, and therefore will have parents. One parent. All right. Now, so this is the constructor, and then the other method that we have here is the render method, which is going to be called from the Razor component you'll see in a minute, and that is the frame updater, pretty much. Once again, we're not going to have anything here yet. Later we will populate some stuff here that we need to do in order that we need to update on every frame, as the Pixie.js calls the renderer for every frame, basically. But right now there are a couple of events there that for every tick we will have 2 events fired by the JScene object. That's before anything is done on the renderer side for that frame or after it. These events come in handy for the, so to speak, outside world to capture what is going on with what is going on before and after each frame inside in the scene. And we have the dispose method here, where we have to kind of gradually dispose of everything that needs to be disposed in the scene, starting with the textures, and then we will have sprite grids later, and there'll be more stuff here actually. And finally, the document, disposing of the document. The document needs to be disposed last. Well, I mean, no, it needs to be, but that's the most logical way to do it. Anyway, what we have, one thing I want to mention here is the render tree dispose, and this is actually, I don't know if we didn't talk about this, because the render tree is a container, J container. So the dispose method here, let me see, where is it here? So here, besides the disposing of the object itself, it will recursively call the dispose on every child of it. And if the child is a container, that thing will call the dispose on every of their child. So therefore, this way, with this method, everything is every scene element in the tree is disposed recursively. And this way, on the JScene, we only call the dispose on the render tree itself, on the root element in the tree, and then this method will recursively call the dispose on every branch and every leaf and everything. All right. One other thing that we add here is a couple of these event definitions, but what we need actually is we need to call this static method on the Pixie wrapper. That's pretty much it. Again, I'm just wrapping this static method for use, so we don't need to. So we have everything wrapped in our scene that needs to be wrapped on the Pixie.js side. Anyway, so this is the scene. It looks fine. Now the next step is we need to create, so this is the view model, so to speak, for our scene. And now we need to create the actual view, which is a razor component. All right, so I've added this razor component that is going to house the JScene in it. Now let's look into it, what it has, and it's pretty short. There's not much in it. The main thing here is there's only one HTML element. There's the div element that has that represents that will serve as the HTML container for the canvas that is going to draw the graphics from Pixie.js, informed by the JScene. All right, let's look at and that there's no other HTML here. There's just one part here for this component. You don't need anything else. It's a pure canvas kind of thing for the JScene, and everything else is WASM. Well, and JavaScript under the hood, I guess. Now, let's see what is the code behind all of this. First, there are a couple of parameters here that we have. Very straightforward. We have the cascading style sheet class for this container, which we can use to style and shape. Mostly use it to kind of size, I guess, your container on the screen with CSS. Okay, so the second one is the background that background color that will be rendered on the canvas, and this one, the auto initialization, is all it does really is when the Blazor render tree renders this component for the first time. If auto init is set to true, then this init method is called, which we will look at it. This is the most important method here. That's all there is to it. Otherwise, if it's set to false, we can have the component not initialized and then have it initialized at like custom time whenever we need it, actually need it. There's a randomly generated HTML ID for the canvas, and we have some references to the application, which is the Pixie.js application. It's this one, the application instance, and we have our JScene that is a read-only property that we will be building with the builder. We don't have the builder yet, as you can see here. We will have that done next after we've looked at this component. So the component also has a couple of callback events, as was shown in the presentation. We have the builder. Was it? I don't remember now. But if not, then there are two places that we have an opportunity for the consumer of this component to run some custom code at the time of initialization. So one is on scene building. This is actually the callback that can be used to add assets to the scene, and then after the assets are initialized and everything else is initialized, we have the option. We have the callback that we can use to start building out the scene using the assets that have been initialized before that. So these are the two events used for callback, and we initialize by default. We initialize this component. Rather, we initialize the scene immediately after the first render of this component on the page. So now let's look at this. This is important. The initialization method itself, and this pretty much follows the Pixie.js pipeline for initializing the scene to a degree, as in we are creating the new Pixie.js application, and then we call the init, which is the same as here, initializing the application here, and this is where we're setting the background, and we are resizing it to the container reference. So the container element, which is our HTML element, is the container element, and whatever the size of that container is at the time of initialization, that will be the size that will be that is the size that the canvas will be resized to by the Pixel.js app object. So after the application initialized, we have the application canvas appended to the to the actual HTML element, represented by our div tag here. And we take this HTML element and we append the canvas to it with the same size as the the containing element. So the div element and then the canvas right inside of it. And after that, so we have everything kind of set up, and now we're starting building the actual scene. And this is where we'll have the scene builder object, or service rather, because we will be injecting this as a service here. I'll talk about that in a bit, in a sec. We will use that to create the scene, the JScene object, as the builder exposes the methods to the callback events, where they can be used to manage the assets and the building process of your scene, pretty much. I don't know if I explained it well, but you will see it. It's pretty straightforward. And these are the callback events that are happening. I was talking about the handling the scene builder. So we're creating the builder, we're creating the scene. The scene is available, and the argument to the callback is the builder itself, and the builder will have, it doesn't have yet, well, because we don't have the builder, but the builder will have the methods to actually create the asset objects or other things like the render layers and other stuff that are kind of pre-populated before the scene actually is built. So when we are calling after the callback is done, the user actions, the user use the scene builder to populate like which assets the scene needs to be loading, and the next, after the callback returns, the next call is, the next instruction is to actually do the building, and this is where the assets are actually loaded and built and things like that. And after that, right after that, we are waiting on this operation, on this asynchronous operation. And after that, we again calling back to the application, to the container application, the user, whatever you want to call it, with the argument of already initialized scene. And this is well, with assets and things. And this is where we can use this scene argument on the callback side to start, building the render tree and or whatever else. You will see as we will do some testing today. So after that is all done, what we do is we are creating a ticker callback, which is the same directly done here, when we have the app ticker add, and then you have this delegate to a function in JavaScript that has a timer parameter, or like the ticker time parameter, and this is the so you call this once, but the delegate is then starts calling the application starts calling this delegate every frame. So this happens, this instruction, this line here executes once every frame, that allows the sprite here to rotate, because you see, like here, for example, it's just adding a 0.01 radian to the well, multiplied by the delta time, depending on how much time has passed between the frames. So this is what makes it like consistent rotation here, and that is just assigned to the rotation property of the container that contains all these sprites, and that is called like many times. Like for example, but the point is this delegate is called every frame, and this is what we have here. We have the ticker object, which is the SpawnDev's wrapper for that delegate, and we can assign our method here to tick every frame. So, and this is where we call the scene render method that we've defined. That has nothing in it yet, but essentially this will be one place that this razor component will be ticking every frame, and the scene will and the ticker will be this method called every frame will call the render method on the scene, and then from there we can do everything that we need on the scene. Kind of like the entry point for frame updates is here. And that's about it. That's our razor component. What we need now, I think the last thing here that we need for this to start working actually is our the builder service. So let's check that out. It's just a class that we define in our services, and then we use dependency injection to inject it here. All right, so I've added this class. The JScene builder is here. And this, again, this is just the first simple stuff that we will be adding to it as we go. But the few methods that we have here, first of all, we have the Blazor.js runtime as an argument to the parameter to the constructor, which means we need to have it, if we use this JScene builder as an injected service, which means we will need to have Blazor.js runtime also added to our service collection by that time. Otherwise, the JScene builder will not be initialized. We will take care of that. And we have the private JScene field here is the one that we'll be building with this builder when using this service. And it kind of, as the builder patterns go, you go in steps, right? So you have a step, and then that step returns the builder again, and then you go to the next step and return the builder again. So the step that we have here is we have the start scene, which will instantiate the scene object, and then append the render tree to it, and clear the texture URIs that we will then be adding using the next step is during. So once the scene is started, now this scene returns the builder itself. Again, it says returns this. So from there we can go and start, say, for example, adding textures. Will be other things, adding sprite rays or whatever else, whatever other assets that we'll need, render layers or things like that. But for now, it's just this method that will be called on that callback to the outside of the razor component. And for now, because this is like, if you see it, the thing is, and all of these building methods, they are synchronous. They're not async, because there's nothing going on in there. Well, besides, I guess, the JScene construction, which is pretty fast, but there's no, for example, there's no HTTP client calling to some URL to get the data from a web resource or something like that. Therefore, all of it happening here inside this single thread of where the service is in the same scope where the service is initialized. And therefore, it's all like, for example, this is just a list of strings for the texture URIs. So when we're adding the texture, we're not actually adding the texture. We are just kind of memorizing the URIs for the textures that will be added later at the build time. So the two methods we have, the start scene and the add texture, these are all synchronous methods because they don't do much. But once we call them, once we are ready to build our scene, then the component calls the async method build. And this is where, for example, the loading of the textures actually happens. So you can see here it says scene textures add, and then the asset loader from Pixie.js loads the texture from the URI. So this operation in itself is asynchronous because it's if it wasn't, it would be locking your foreground thread for potentially a few seconds, depending on where that asset is stored, or how big it is, and things like that. So therefore, the call to build is asynchronous because the asset loading is asynchronous. So this is what all we do here. What we do is we, for now, are loading the textures, and what is going on differently here is that the other building methods, they return the JScene builder itself. So the method is called, some stuff is done, and then the builder returns. But for the build method, which is not even a public, you see it's internal because the JScene Jerboa scene razor component is the one that's calling it. It's not the outside view, it's not in the callback. And it returns the scene itself. Like for example, if we look at the component, back at the component, here, we are calling this build method. Jerboa scene, hold on. JScene builder. That we are calling the build method and are waiting for it, and it returns the scene that was instantiated when we call the start scene method. So we're starting the scene object is instantiated, then we are giving the consumer the opportunity to build out the assets, and then which is fast, and then we are, well, supposedly, depending on what the consumer does actually, but then once that is done, that's when we are building, and that's when the assets are loaded and the scene object is returned by this build method. And then we are calling back again to the consumer with the finalized scene object to give the opportunity for the consumer to do more stuff with it. All right, and that's pretty much it for now at this point. And now, let me see, this thing builds, we're fine. There are a couple more things that we need to do here though. And that one is the service that we created here is just a class, but we need to add it to the service collection. And remember yesterday we added this dependency injection infrastructure, and I have this here, adding services, so this is where the services will go. Okay, so I've added these two services, and remember, as I said, we've added the builder service, but because the builder service requires the Blazor.js runtime, we need it injected. We need it already injected at that time. No, we need it in the service collection to be injected here, and therefore we're adding the Blazor.js runtime here before. We're adding the Blazor.js runtime here as well, so we will have the JScene builder service initialized properly. And now in the Jerboa scene, we will probably need it later, but I'll get rid of it for now, because we will have the JScene builder is the only thing here that needs the JavaScript runtime, and that is injected automatically on the when the scope creates the scene builder service. Anyway, so this is that. Do we need anything else? Yes. One other thing we need one extension method. And let me quickly show you what it is about. In our SpawnDev's Pixie.js, like if you look at his example, you can see here, so this is the WASM application that this is the WASM application that uses his library. Just an example here when the application is initialized. And there are two things here. We have this Pixie.js init initialization method, the static method, that says loads the Pixie.js JavaScript library that can be called in a component instead of desired, blah, blah, blah. So this is what we've done we wrapped this call, because it actually loads the JavaScript library with Pixie.js into Blazor. And we've wrapped it into our static method on JScene, if you remember. So this is where we're calling it. So we need to call this method in our application when the JScene, when we are initializing the scene and everything else, and building the services. So, and another thing, that's one thing. And another thing is we have this, after the builder for the WebAssembly host builder is done, what we have is usually out of the box, we have the builder build, and then we get the host, and then the host has the method that's called run async, and that was cool. But SpawnDev wrapped that method into an extension because at that time he needed to perform some actions before the application runs. And now what we need to do is we need to do the same thing. We need to wrap his method into our service or the extension. And that is done with a simple extension to the host class. So that is done with this. I have added this little file with code. It's called extensions, and I will be adding more extensions here. But this is an extension method to the WebAssembly host, and so all it does here, this extension method, it takes the WebAssembly host and just kind of forwards the run async to the Blazor.js run async, which is this, and we have our own wrapper for it. And if we need, we'll add more stuff to it at this time, and we will be using this and injecting as we are building our application. And that's pretty much it. So this is all we need for us to actually draw something on the screen with this. So let's do that. For that though, we will need a test application. I am not going to, I mean, we could like write it right into the game client that we've created, but let's not do that yet. Instead, what I'm going to do, I'm going to create a folder here, a solution folder. Call it tests, and I'm going to add a WebAssembly application to it, the WebAssembly only Blazor application, very simple one, so we can quickly test all of this. Okay, so I do add, and I'm going to add a new project, and that's going to be the Blazor WebAssembly standalone application. All right, next, I'm going to actually put it in tests here, and I'm going to call it, test scene. Next. And this is going to be the .NET 9 with nothing, and we're just going to create this. I'm going to set it as a startup project. All right. I'm going to set some things off screen here, and then I'm going to come back and explain what I did, and then we will run it, and we will try to draw a sprite on the canvas. And that will be it for today's video. All right, so I've added some stuff here that some of it does not work yet because we need to add some dependencies. And then I'll add those dependencies and then we will talk about this little setup for testing, because we will be reusing it. That's why I took the time, a little bit of time, to actually set some of it. It's not that much, but it will be useful for further test. All right, so what we need a couple of things. First of all, we need a reference to our project, add project reference, and we actually just need the J parts, because the J parts then reference the JScene. It will cascade down to it, so we can just add this. As you can see, project, J parts, and then we have the JScene, that is this. Now, yes, we need to update the WebAssembly later, but one thing is this one, the package is the WebAssembly is one minor version behind what we need. So let's do that right now. Update the WebAssembly packages. That should help us with all of these errors. All right, now the JScene. Next thing that we need is what is it? What do you want? I think we're good. J parts. Next thing that we need a another package here that we will be using is the Bootstrap wrapper for Blazor, which is this one that I talked about before. And that one is also pretty straightforward to set up. We can just go to docs, and here we have all of the information we needed for Blazor WebAssembly only. So we're just going to follow these instructions. We're going to install this package. Let's copy this and run this in our package manager. And this would be for the test scene. That's correct. So we're going to install this, the Blazor Bootstrap. Good. The next thing we need is so good. Next thing we need to add a few things to our index.html file, which is the links to some of the style sheets here. And actually, I'll just copy it and the scripts like this. That's all we need. And we also need to add the services to the Blazor Bootstrap services to our builder, our service collection, which is here in the programs. Actually, I already have it here, all sorted out. Now let's look. Let's see if it builds. Right, because I also need to add the last step that I didn't do is the add the bootstrap to the using in the imports razor. Which is not necessary. I mean, you could just put the namespace explicitly in your page, but we can do it all in one place here. If I do it here, I can just add it like this, and that should take care of those warnings. And there's always one last thing, isn't it? And that is, let me just quickly do this. Where is it? Pages. Give me just 1 second. I think I have one class that is not defined in our cascading style sheets. It's not that important, but I want to do it now, so we don't need to worry about that later. And I'm just gonna, all it does is gonna it's going to set the aspect ratio for our canvas, because the canvas width is going to be dynamic based on the Bootstrap container size, but I want to keep the aspect ratio for the container consistent with the width. So all we need to do is set the aspect ratio to, yeah, let's do 4/3 since that's what it wants. Just like the old, TVs, right? All right, so now this is the class. Okay, we have one test, which is a simple sprite. Voila, we have liftoff. So this is a single sprite, a bunny sprite, that is loaded then from a URL, then built into the scene as a sprite in a container, and then drawn on the screen in the middle with some transformations. And let's see how we did this using our JScene library that we just built. Now, let's start with the program.cs, because this is where the program starts. This is all the standard stuff. We have the standalone WebAssembly host in our application. We have the HTTP client. That is also something that the WASM host application injects by default. And this is the stuff that we've added. And here we have the Blazor Bootstrap service from here, the one that we added here, if you remember. And these are our services. Well, JParts is empty right now because we don't have anything in JParts. It's just like does nothing. But the JScene is the one that injects or rather adds the Blazor.js runtime, JavaScript runtime by SpawnDev, and our scoped JScene builder service into the application. Then we call this static initialization for the this is what loads the JavaScript code into the application into Blazor dynamically, and then we are running the application by calling our custom JScene runner sync that calls the SpawnDev's runner sync and so on and so on. So this is the program. And then what we have here is that we have at the root of our web app, we have our, of course, the index.html file, because this is just a client-side WASM application. There's no server part to it. It starts with a static web page. And then the static web page then compiles the WASM, compiles the WASM and runs it inside this HTML container. There's nothing there. All of the stuff that we've already added. There's nothing that we do here that we need to do. So I'm not going to look at it too much. What I did though, we have a home page, and we have a layout for the whole that we'll be using for the home page and for everything else. And the idea was to have like a home page with buttons that takes us to pages with different tests that we will be adding. And we've added one. I've added one, this the Sprite test, and there will be more pages as we go adding to this test rig. The one thing here I want to stop a little bit on. You can look at the code and see for yourself, so I'm not going to spend too much time on it, but it might be interesting. One thing with Blazor is that I wanted to have like a dynamic header for the page with the name of the test that we are running. And for that, I have the main layout set up like this. The thing is, in order, so I'm building out the title with the title of the test dynamically, and the back button if we're in the test and it's not showing when we're on the home page. You can look at how this is done. It's nothing complicated, but the idea here is that this test title property here, it needs to be set by the page, from the page into the main layout, and that needs to be cascaded down. So there's a in Blazor there's a method to do that with the cascading value. When you wrap the entire HTML for the layout in cascading value and provide the value as referenced by the actual instance of this main layout component, this property is exposed to the pages through referencing the layout. And I'll show you in a second. Right. And now, if say, for example, we have a home page, we can, it's not only pages, it actually the nested components as well, because I just wanted to clean up this whole thing to a point where we don't need to, the individual pages are very straightforward. Like, for example, the Sprite test, this is all there is to it. So all of this other kind of housekeeping stuff is hidden in components. And that is why Blazor is so great, is because it is so kind of modular. The way you can build out your application is not like you're building a web page or build your JavaScript library or whatever else. It's just a components. It's a relationship. It's a tree of components and a very kind of flexible relationship between all these components. So, for example, I have here the test scene page title component, which is actually cascading down to the main layout, sets the title based on the title set in the parameter of that component, and at the same time it says the title for the page. And that is completely encapsulating the whole thing separately. Like I can reuse this component anywhere I want. I just made it, and I can, wherever I use the page title, I can just replace it with this with this component, and that's it on the page. Like, for example, if we look at the home page, instead of doing something like this, as it was originally there, like if I want to have a page title, I would say, yeah, I would have some JScene tests. Like I would have something like this originally. All I have to do is just take this and replace it with this, and this component will have the title set as well as the main layout title set as well through this cascading parameter. And all of this is done in just like one line here. And I don't need to touch anything else. And I can reuse this line on every page, and that's it. Very straightforward, very, very nice. So I can actually focus on the content of that page rather than all of this, noise around it. That's why I really love Blazor. It's one of the reasons. It's not just this reason, but there are many things. Anyway, but I digress. Let's look at what we're doing here. So the home page is very simple. We just have a list of buttons. For now, we only have one, and that's again wrapped into this nice syntax, Razor syntax, where all we have to do is, later is if we want to add more tests, we just add more tuples to this list, where in the tuple we have the name and the URL to the test. So the first one we have is a simple sprite test, and the URL is just sprite. Next we have the sprite test. You see, this is the home page. And in the sprite test, we have the sprite page. This is where the magic happens. Again, I have my test scene page title set to this. This will set the page title as well as the layout title and label, whatever. But this is where we have our stuff. Inside a container, we have a row and a column. This is the normal Bootstrap table cell. And this is where we have our Jerboa scene. This is the component that we've created in our JScene library. And all we have to do here, well, we set the class because this is the aspect ratio thing that we can set the background color to what we want. And these are the two callback handlers that we need to handle to load the assets and then make the sprite. And this is the only pretty much thing that we are doing. So we have the scene reference, which is the Jerboa scene Razor component, has an encode reference here as the Jerboa scene class, which represents our view for the JScene. Again, we're not using it for now for anything. We don't really even need it, but I'll leave it here for now because we will need it for future videos. But the two methods, these are the handlers, the scene build handler to load the assets, and the scene init handler for this to build out the scene after the scene has been initialized. And all we're doing here, we are loading a texture into our builder. You see the argument for this is the builder, and the builder has a method to add a texture, and we are providing the URL, which is from the Pixie.js website. We're just going to use that little bunny that they're using for their examples. This little bunny sprite. or rather image, which is a URL. So the texture loader will actually grab it from the web, but you can also, of course, for the actual game, the assets will be distributed along with the game. So we will have the assets in our folders here inside the inside our solution, because that's our assets, and they will be deployed to the web along with the web application. For now, we're just going to use this. Well, I mean, in the next video, we'll already start using our own assets. This is just the very first kind of hello world example. So that's why. And as I said earlier, when we're adding the texture to the builder, then the component calls the build method. It will actually load the texture asset and populate the dictionary where the key to this asset and dictionary is going to be its URL. So we can later retrieve this texture from the scene, from the JScene textures, by using the same URL as a key. All right. So this is the asset building, and now the scene is built, and now we will use this asset to draw the sprite on the screen. And this is a few lines of code that we will do it with. First of all, we are going to create the JSprite object that we defined the class earlier today. I'm just going to go bunny, and here's the constructor. Look, this is interesting. What happens here is that when we call the constructor, we're supplying the render tree of the scene as a parent. So we will directly draw this bunny like under the root of the scene. What is the texture that we are going to use for this sprite, which is our bunny, and just the name. And you see what I'm doing here. I just instantiated this bunny, right? This object, but I did not actually explicitly add it to the render tree, because if you remember, that's the containers handle all of that under the hood. That collection has the event, that event is traced, blah blah blah. You can trace it, but that's all I need to do. All I need to do is just instantiate it, give it the first argument as the render tree, and this sprite it is created, and then it immediately added to the render tree under this parent. And then after the bunny is there, we can just assign some properties to it. And all I'm doing here is I'm setting the pivot point of that bunny in the middle of the container, because the bunny container has the width and the height property. I'm just dividing it by 2, which means it's going to be this point of the pivot for the sprite is going to be right in the middle of the sprite. And then positioning in the sprite the X and Y position on the screen in pixels. Is going, well, pixels multiplied by the scale of the screen of the I would say factored by all of the scale, like multiplied by all the scale factors for all of the parents. But since we have only one parent and the scale factor is 1, so it's pretty much pixels position. We have the scene application screen object that is a wrapper for Pixel.js screen object by SpawnDev. And we have the width and the height of the screen, which is not the computer screen, but the canvas on which is drawn, the actual, the scene screen, so to speak. We're also dividing it by 2, meaning we putting the bunny right in the middle. And since the bunny is so small, I decided to also scale it by the factor of 3. So both the scale X and Y set to 3, and that is all. That is the entire thing. And we've come full circle. The most basic example of having all of this all set up for further development. And there will be a lot of stuff for us to cover. There will be a lot of more interesting things to look at and to leverage, as well as overcome some interesting obstacles. So I hope you've enjoyed this. I hope this is something that is interesting, because it is interesting to me. I'm hoping to find people who will find it also interesting, and we can all enjoy this stuff together. That is the idea. In any case, let me down in the comments if you have any questions, or you have any suggestions, or you have anything to add or critique, anything. Everybody's welcome, of course. And thank you so much for staying with me so far, and I hope to see you in the next video. Let me actually, before I say bye, let me run this again so we can all see the beautiful pixie bunny on the screen, rendered by WebGL through all of these layers of different stuff. Ta-da!